Okay, so now we move to our dear friend Hans. Hans comes from Infineon, and Infineon is the biggest supplier for chips all over the world. We have met Hans several times, and each time we meet, he always gives us fantastic information, shares a great experience, and he gives us first-hand information, as they say. I attended with Hans 2 weeks ago an event with university, and it was quite impressive. I was very impressed, and I'm super excited about having Hans with us today. Hans, the floor is yours.
Thank you, Shireen. Can you see my screen and can you hear me?
Yes, we can hear you and we can see you, and it's fantastic.
Okay, and you can also see my screen, right?
Yes, we do.
Okay, great. Then thank you very much, and it's my pleasure to be here today, almost real in Cairo, but unfortunately just on a virtual event. So I want to bring you for the next time into the semiconductor supply chain and also to the global chip shortage. A few words to myself. So I'm heading some supply chain innovations department of Infineon, with taking care of knowledge, academy, and the audits of partnership, simulation and trends, artificial intelligence, deep learning, and quantum algorithm, where I don't want to talk so much today, digital supply chain for decision support, and the semantics and knowledge graphs for complexity management. Some additional commitments. There is a large organization in Germany for electronics. It's a ZVE. It has a working group on supply chain management, which I'm leading. And in Europe, there are funded projects. One is in the arena of Excel, and there we have funded projects like Productive for Zero, and one it's called Semantically Connected Semiconductor Supply Chains, also something which we need later on maybe to solve sustainable chip shortage problems. I also was a former board member of APIC Supply Chain Council. Supply Chain Council is the founding association behind SCORE, and this is now run by ASCM, and Douglas was just before from ASCM speaking to us. I have structured my presentation into first, I want to bring you into the challenges of complex semiconductor supply chain, then to our answers via the global flexibility. Of course, we have this implemented, but it was not enough to overcome the current global chip shortage, then the reasons, the root causes for that, and then a collaborative way out of this global chip shortage on a sustainable way, first thinking about that, and then coming to an executive summary. When coming to our global challenges, first a few words about our company. My company is Infineon. We are a provider of semiconductors. We are one of the top 10 semiconductor companies in the world, and the largest one in Europe. And here you see our turnover of the fiscal year 21, which closed in October, with 11 billion turnover and 2 billion segment result. We have globally 50,000 employees, and where we are engaged in automotive and power, we have a #1 position, and in microcontroller, a #3 position worldwide. So now let's come to the challenges for semiconductor supply chain, and there are basically 4 big ones. One is that semiconductor itself is very capital intensive. When you compare the money needed compared to other DAX companies in the German stock market, then Infineon has the highest appetite for invest. It's no wonder because a new fab costs €1 billion, and because it's so capital intensive, all semiconductor operations work 365 days a year, 24 hours a day. The second challenge, and to this one we will come a little bit more in detail later on, is the so-called bullwhip effect, the amplification of the demand along the supply chain. We have a volatile demand, and if you look, for example, here on the global gross domestic product, which is the blue line, and if you look for the semiconductor market going back to 2005 up to today, then what you see is that the shapes are almost the same, but the scale is here from -12 to 12% concerning the fluctuations. and the semiconductor is fluctuating from -6 to 60. So we have an amplification of the fluctuation by a factor of 2. And on top of those challenges comes the challenge that wherever you have a product, wherever you have a semiconductor in your product, the product itself doesn't live so long. For example, look at black and white TV, how long it took until it's in high volume and how long it survived. Color TV, and then global standard for mobile communication, and then iPod, iPhone, and so on. So the higher the semiconductor component in a product, the sharper it's going up when it's successful, but also it's going down quite fast because the next semiconductor is already better, disrupting this final product already. On top of that comes a very long intrinsic cycle time of semiconductors. So you can, a semiconductor not build like a car, you cannot parallelize the things. You have to build one layer after the other, and this one layer after the other, that takes a time. So producing a semiconductor is 3 months, sometimes 6 months and longer. So when we have those challenges, how to manage that? So first of all, for us, and this is already quite a time ago, we started to structure it according to the SCORE model with plan, source, make, deliver, and the return processes. In the centers, this very complex make process. On the left-hand side, we have our suppliers, like those for raw materials and for gases. Then, of course, the make process in the center with our own manufacturing sites. For the front-end parts are done by so-called foundry partners, and the largest one is TSMC in Taiwan. And also for the back-end subcontractors for doing the back-end. So in the back-end, based on the business cycle, 20 to 50%, and in the front-end, maybe 10 to 30%. And on the right-hand side, you see the customers, and on the right-hand side of the right-hand sides, you see the OEM like General Motors, or like Volkswagen or Tesla. Then let's look at our answer to those challenges, which is the global flexibility. And we are saying that our supply chain is one global virtual factory, and for this one we provide flexibility. But why actually we think that is a good answer? For that, I need to tell you a bit of a story and coming into the semiconductor world. I already talked about that the new fab costs €1 billion. An equipment for lithography today may cost up to €10 million. And all wafer fabs in the world are structured like that. You have aisles with equipment, and the wafer needs to go back to lithography and also to the other processes. And that's up to 1,000 process steps until the silicon wafer is finished. And with this lean for complex flow production, it was possible to reach both a good utilization, which you see here at % utilization, and a good flow factor. Flow factor is a relationship between cycle time and raw process time. So a small flow factor is being fast. And the blue curve here is much better than the red curve, because on the blue curve, having the same speed, you have a much better utilization, so a much better cost position, especially when most of the costs are capital costs because of the high invest. This alpha is the measurement of volatility for material, man, method, and machine. And if you get this alpha small, then you also can move from a blue curve to a red curve, from the red curve to the blue curve. And that is basically this operating curve management. And also when you want to click here on this lean for complex flow production, of course, you also get the slides. And then you see what is the miracle behind the speed of semiconductors in manufacturing. That is this operating curve management. But why I'm talking about operating curve management and manufacturing when we want to talk about supply chain? The reason for that is because when Infineon was not in such a good cost position, or not in such a good position back 2009, we figured out transferring this flexibility which we had on a wafer fab level, this network thinking, to the global supply chain. We are in good position. What you see here is a supply chain for an ultra low-cost mobile phone, which we produced in 2009. The fab was in Germany. There was a process only available at the subcontractor at bumping in Taiwan. Then it came back to Germany for testing, then for assembly in Singapore and out. The second supply chain was already a little bit more cost efficient and also faster, as Singapore at that time had a better cost position than Germany. And also Singapore, of course, is closer to Taiwan than Germany. So that was an efficiency increase with the second supply chain. But already from the third supply chain, we came into a situation where the customer wanted more supply, but the competitor, where he wanted actually to buy the supply, could not deliver because of technical reasons. We didn't have any test capacity anymore in Germany nor in Singapore, but we had test capacity in Altis in France. So that was the third supply chain. The situation continued. Bumping subcontractor in Taiwan, the one didn't have capacity, but another one built up capacity. So it's the fourth supply chain, and it continued like that. And which is less than 9 months, we managed to get 13 supply chain running in parallel. So what we learned from a manufacturing level, we could transfer to a supply chain level. And by doing that, we came into a position saying more often yes to the customer by flexibility. And if some of you may know the share price of Infineon at that time, we were below 40 cents. Today we are at 40 euros. So it also turned out to be business beneficial. Of course, supply chain was not the only reason for this success story. So that is the reason why we think having the global virtual factory as having the supply chain as a global virtual factory is good for us. But what I showed now is a make flexibility. You can't do this for one product. But if you have many products, like for us, we have 10,000 stock keeping units, then it's not manually possible to take benefit of some implemented flexibility which you have in the make process. So you have to think, can you also implement a planned process which takes advantage of this implemented make flexibility, possibly on a daily basis? As many companies, you have different planned processes, from looking very long into the future with coarse granularity up to finer granularity, up to several further planned schedules in the make process until it comes to manufacturing execution. So for us, the flexibility we built into this production program, and here we again followed the SCORE model with plan. So talking about aggregated demands and aggregated capacity, aligning them, and then coming to order management. But how this looks in detail, you will see on the next slide. So the next slide is a little bit overloaded, but if you remember, orange is demand, yellow is capacity, and green is the matching of demand and capacity. Then for order management, the violet, and for gray for production management, it's easier to read. So when we look at this process, how it is implemented, then you see here the operational demand. So that is coming from orders, VMI and EDI forecasts, and also order expectations, and also the stock targets. So how much you want to put on stock. So here we have a couple of 10,000 demand elements which can be changed on a daily basis. Then when we come to our several factories, which you have seen on the other screen, there are a couple of thousand bottleneck capacities, and those demand elements and the bottleneck capacities are then matched via a hierarchy and heuristics in the advanced planning system. Out of then comes on daily basis a couple of 10,000 ATP available to promise. An ATP is not only what you have on the distribution center, it's also what will come to the distribution center for the next 26 weeks, sometimes for the next 52 weeks. And based on this ATP, then you can have an order confirmation. So the orders then grab on a daily basis the ATP, and then you can do the order confirmation. And for us, we have about more than 1 million order elements. We have more than 1 million order elements in our system. On a daily basis, 1 million order elements. Most of them are reconfirmed like yesterday. Quite some get an earlier confirmation date, earlier to the customer wish date, and as a collateral damage, also a few get a worse commitment date. But this plan process actually implements the make flexibility for which I have talked before. Sometimes I get asked, does this all need to be so complex and so complicated? I have not really a good answer for that. We have found no better way, but if people look at us, they also give us sometimes awards. So probably when you want to run a global flexible supply chain, you have to think about implementing not only the visibility, but also this ATP and having a good commit to be able to run that.
So Hans, I have a question for you because you're explaining lots of things, but very fast, okay? So
yes.
The ATP you talk about available to promise, it's
That's
not
correct,
only what
yes.
you have, it could be up to 52 weeks.
Yes, it's true.
So you have this available to promise will be by time phased or just a quantity?
That ATP is how the ATP in the future is how much volume from a certain product comes in a certain week.
Okay, okay. So
yes.
this is run. It's transparent, open to all salespeople or supply chain people.
That is our internal ATP available to promise, and when orders come in, they grab this ATP.
Okay, so it's not visible to sales team.
This is the ATP. So the sales team sees when the order gets confirmed.
Okay.
Of course, they can also, if they want, they can also look at the ATP. That is true. But what they are interested is in order confirmation.
Okay. Okay. Very good. Okay.
Okay. And for this ATP is done every day based on the demands and on the bottleneck capacities. Once a day comes a new ATP. And what I didn't talk about is this production commit. So when outside, when something is not yet started, not yet in manufacturing, this automatic system generates this ATP on a daily basis new. But when something is already started, then we have a production commit. So it is not fluctuating so much within the next 4 to 5 weeks. But outside, there are about 500 people who optimize the demands on a daily basis, the bottleneck capacity on a daily basis. And then on the next day, you have a better ATP, a better global ATP.
Okay, okay. Thank you very much.
Yeah. And what I didn't talk here is about an AATP allocated available to promise. This AATP allocated available to promise is an allocation situation. When you do not have enough ATP, then you may already reserve some ATP for certain customer group or for a certain region. But else, this one is optimized on a daily basis. So you have implemented flexibility in your global supply chain. And this global flexibility is optimized on a daily basis. So to get a better ATP, to say more often yes to the customer on the order confirmation the next day. And the tool here is from Blue Yonder, but there are several companies who provide those tools. So this central tool is from Blue Yonder. The order management is from SAP, but the flexibility is here by this Blue Yonder tool.
Okay, interesting.
Yep.
So, so yes, it's good about you sharing the awards. Please go on, please.
Okay, now let's come to the current. So I wanted to tell this before because before the chip shortage was coming, this was basically a system which was quite robust and it served us very well for doing good. But then came the chip shortage, and when the chip shortage comes in March 2020, many consulting companies were coming and asking, what kind of recovery do we have? Do we have it as a U shape, or a V shape, or a W shape? And almost none talked about the so-called tick mark recovery. So going down a little bit and going much higher. And that, of course, caused then the chip shortage. Of course, always when you have, let's say, a risk, we like this Japanese or Chinese wording of a risk. A risk is on the one side a danger, and on the other side also a chance. So I will also talk about the chance a little bit in the later part. So when we talked about this chip shortage, we basically had one big challenge is that the thinking of just in time, which was also mentioned by Douglas before, met now with this complex and capital intense semiconductor manufacturing with long lead times. And those both didn't really work well together, especially not in pandemics. And why is it like that? I would like to elaborate a bit on that. Whenever we don't understand what happens, we simulate. So we have quite some experience on simulating on cluster and equipment level, also some good experience on simulating fab level. Recently, also good experience on managing this internal supply chain, both on the make process and on the plan process. Of course, if you have a tool implemented, as I mentioned before, you want to also simulate when you change something to see the problems. But now for this global chip shortage, we needed an end-to-end supply chain simulation. And for that, we built up an end-to-end supply chain simulation. And I would like to show this to you now. So this end-to-end supply chain simulation started with an OEM, with both the demand signal, which goes upward, and the physical flow downward, with the tier 1, the tier 2, and the semiconductor instance. Now, when we looked at the demand signal, and we had two demand signals, which we knew quite well. We had the green one, which is the light vehicle sale. So we did it for automotive market. We had the tier 1 and the tier 2 we estimated. And that was the semiconductor demand signal which was received. And the semiconductor demand signal we had from our own company, that is the black line. So what you see between the green and the black is actually this bullwhip effect. So the demand signal was accelerated. So the demand appeared for us much lower than it was for the OEM. Of course, then afterwards, the demand signal, and that's where we are now, may also have some overheating in there. So when that was the demand signal, so how did the inventory basically look like? In our simulation, at the beginning, the inventory increased everywhere. For semiconductor, it increased a lot. But then for integrated design manufacturer like we are, somewhere the risk was too high. And of course, you cannot build up too much inventory, so there was a certain risk cut. It's a so-called silicon foundries. This risk cut for the automotive industry was much earlier because, of course, during pandemic, especially communication needed more semiconductors, so the risk cut was much earlier. And then when the demand came in again, the chip shortage occurred. And where we are right now is this product-specific collaborative way to get out of this chip shortage. So after having this understood, we also found out that this bullwhip effect, so this amplification, which I talked before, is nothing new. When we looked at crisis, it's a dot-com crisis in 2008, 2002, we already had that, so even higher. So again, global gross domestic product and semiconductor market, but here's a difference between left and right is actually a factor of 12. And also in 2008 and 2009, and this is this bullwhip effect. Humans just tend, if they have nothing on stock, they order twice as much, and if they have too much stock, they order nothing. So the easiest answer might be semiconductor just to produce faster is not so easy. And for that, I also brought a picture now of a semiconductor just to reflect what semiconductors are. So that is a microcontroller. And if you look at a small cube on this microcontroller, just this small red dot, and if we look how this small red dot, this cube is looking like, we have here a hair as a comparison of the size. Then we see here the three-dimensional structures. That's where the semiconductor is. And that's where this one layer after the other, which I talked before is. So here is the transistor, and the green ones is just to bring the electrons fast to the transistor. So as this is one layer after the other, you cannot parallelize that. And that is also the reason why it is so difficult to improve the speed in semiconductor manufacturing, as you have to make one layer after the other, and you're already working 365 days and 24 hours a day. So if it is like that, and this picture may show that this network thinking was not only in semiconductor manufacturing, It also came to semiconductor supply chain. This may also come to car manufacturing if you look at some of their future thinking how supply chain may look like. So if this is as a root cause, this not enough demand and the amplification via bullwhip, so what is a possible way out? So just to reflect on those pictures again, this bullwhip effect was already there in 2008, 2009. Actually, today it's smaller. Here it was a factor of bigger than 5. Today it's just 2 to 3, but we feel it much higher because semiconductors play a much more important role in most of the supply chains today. Though the issue is that this just-in-time thinking, where we have a high dependency from the supplier, met with an industry with a very long, intrinsic long cycle time. So how can this one overcome? And for that, Shireen mentioned it, we had a university evening on November 11th in Munich just a couple of weeks ago. And there we also had a panel discussion. And besides the panel discussion, we also asked our participants, we had almost 200 participants, 175 took part on the voting. So what is actually the biggest challenge? So it is this volatile demand and the strong bullwhip. So what are the ways how to master that, what I managed before? Global flexibility in the make process, execution via the plan process, and orchestration that by superior master data, which enable a best of breed IT solution. I mentioned before Blue Yonder and SAP, and all three of that is the way how to manage this well. But then when it comes to the root cause for the chip shortage, what is the reason? So the missing orders and the acceleration via bullwhip came here as those which was the root cause for this chip shortage. And when we asked how to overcome this chip shortage, there were two main answers. The one is reducing this bullwhip effect by improved tooling. So now no steering via region disruptions, and the root cause finding in BMI measurement, and improved collaboration overcoming the bullwhip effect with semantic web. So for both, I will give a little bit of a glimpse. What does it mean? When we talk about vendor managed inventory, and I think many of you are in supply chain, and many of you know this vendor managed inventory approach. Vendor managed inventory means you have a min and max, and as long as you stay within, everything is fine, but you also need a forecast. And the replenishment is often managed by reach. But if reach, and for example, here you have a stock maybe of 1,000 and a demand of 500, then you have a reach of 2 weeks. Now, if the demand is halved, so not 500, but half, 250, then the reach is doubled, because 1,000 by 250 is 4 weeks. So now if you replenish by a target of 2 weeks, you would not replenish it at all. Though the first demand is only halved, but then for 2 weeks, the next one is not asked for any order at all. So that is already an intrinsic bullwhip. This one is, of course, during a pandemic, very, very bad, especially when the one who replenishes has a very, very long lead time. So as said, as long as we don't have pandemic and you are within a min and max, everything is fine. But if you run out of min and max today, both might be unhappy. The supplier, I provided everything according to the forecast, but the customer took everything out of the stock, and the customer may also be unhappy, saying, "Okay, I gave you min max, and now you are no longer between this min and max." So here we looked at that and we came up with a solution. So we measured the daily performance, aggregate to a weekly, and then we compare with the target. As long as we are within the target, everything is fine. But if we are not within the target, we also look at the forecast accuracy. And if the forecast accuracy is within the target, it's clear responsibility of the supplier. But if the forecast accuracy is outside of the target, and if you have a bias, so not just a little bit of fluctuation, then when you have this bias, it's also a customer's responsibility. By implementing tools like that, the vendor managed inventory min-max in addition, with a forecast accuracy measurement, finds out clear definitions and clear responsibilities, and you come out. But for that, you also need a good forecast. But if you need a good forecast, then probably today, this forecasting, you will no longer do by humans. You may do it by machine learning and artificial intelligence. And what we found out when here, every green dot is one plant position and everything's above as a violet diagonal, there for this plant position, the artificial intelligence forecast is better. But we still have many plant positions where the human forecast is better. So we have to find a way how to collaborate with AI, especially in a situation where these AI machines are not able to explain what they come out. So we think that gaming is important to learn how to work with AI machines to learn that. When it comes to forecasting in a quite complex manner, and Douglas mentioned this before, you need to know not only the next one, the OEM, you need to know the tier 1, the tier 2. So you need to know the structure behind that. And for that, the semantic web is a good approach for that. Semantic web might be not known to many of you, but you use it on a daily basis. In Google, when you key in a question and the answer is completed, behind is the semantic web, knowing what you want to ask. When you at Amazon or at Alibaba, when you order something and Amazon or Alibaba tells you who buys that, usually also buys that, behind that is a semantic web. So in manufacturing, the semantic web could do a very good job in understanding what is the connection, between the different partners. And for that, we developed this digital reference. The digital reference is the semantic web for semiconductor and supply chains containing semiconductors. When we are there, then we probably come to the conclusion that today we are no more in a company-to-company competition, but in an area of supply chain to supply chain competition. And for that, we also need to be aware that we need collaboration. So what I'm doing right now today with you, we also talked about this in different other conferences, discussion rounds, also have associations with us who can implement such tools. By that, we may be able to have in the future tools where this collaboration is implemented. One of that will be the Z4E working group supply chain management. But if I summarize before, what are the top findings out of this high chip shortage? On the one side, for us, at the moment, high efforts are undertaken with capacity increase. For example, we invested 1.6 billion in a new fab in Austria. Also, for example, in Malaysia, we were allowed to vaccinate the people. So there was vaccination from 19th of July to 18th of August, and 95% of the employees, almost 10,000, got vaccinated in this time period. Then there are supplementary European and global collaborative activities, like I showed on the slide before. And of course, we need awareness that on local and on global level, that this collaboration also needs understanding and needs tooling and needs awareness that we can overcome these global shortages in a way of collaboration on top of the competition, which of course we need and we still want between the companies. One of those platforms which we implemented is this working group supply chain management at the Z4E, where we on the one side talk about vendor managed inventory, how we can better collaborate on lead time measurement, education and workforce, and on the semantic web and the knowledge graph for implementation. This working group has around 100 members and 30 companies at the moment. When it comes how to solve the bullwhip, it's only that we do it together. Though I brought up a few topics, maybe when we come to discussion, you may want to come back to that. On the one side, it's activities for higher inventory in the automotive supply chain on very short time, which is ongoing now. possible survey from an association, maybe the US BIS or the ZVI or the Arbeitskreis just in time, to understand that which semiconductor products and nodes there is still an allocation increase, there's a smoothing or an overheating. Anonymity is important, so the US BIS already had a survey for that. For the midterm, AA-based and mid and long-term forecast on semantic web. So understandable and interlinked is of course here important. It has to be anonymous. Multi-party computing gives us a chance to be anonymous, and this forecasting also needs to be accepted. So this human AI gaming might be important. There's another way. There's a monetary enforced reduction of the bullwhip with lead time-based pricing, like revenue management in the airline industry. Of course, we all, when we fly, we know when we book early enough, it's much cheaper than when we book last minute. And when done this one and transfer it to the semiconductor industries, this would be lead time-based pricing. And by that, also a risk-taking for selectively high inventory would be rewarded. So that would be another option. Now let me come to the executive summary. So I think I brought you a little bit into our history. We started with a score model, then this lean for complex flow manufacturing on a wafer fab level, then coming to the global supply chain, first flexibility on one or two products, a make focus, then implementing this into a tool system. At the beginning, it didn't really work, so we had to fine tune that after 2 years. Once this one was implemented, and thanks, Shireen, for your question. Yes, it is an ATP for the next 26 weeks, sometimes for the next 52 weeks. And when you want to change something here, doing that via discrete and agent-based simulation, if this is in place, also mergers work, like the one for a couple of billion with International Rectifier. Now we see a digitalization boost with semantic technologies, AI and deep learning. This human AI game might be an enabler to work better with AI, because AI is not able to explain its results. And we see for this year and for the next years to harvest the benefit of the semantic web with better end-to-end collaboration with associations. I also think that quantum annealing and universal quantum computing is not so far away. I didn't talk about that at all. So this could help us to not only have a tool which does this, but also have a faster possibility to do simulations here. So here quantum computing could definitely help us. There is a merger. We already bought Cypress, and this merger is also a challenge for us. So after this executive summary, I just want to have a last slide, which comes back to sustainability. And when we looked on semiconductor, how much CO2 we need for producing the semiconductor, and if we look how much CO2 we are saving by the lifetime of our semiconductors when they enable better power control, better solar performance, more efficient machineries, then we have a very high positive factor. So I think it's worthwhile to also reduce this bullwhip effect, because then we have more semiconductors. We can save more CO2 by being much more efficient. And for that, I say shukran. Thank you very much for having me here today. And I hope I can, out of my home office, answer one or the other question from you coming up now. Thank you very much.
Thank you very much, Hans. It's impressive. Okay. So we have, can you take a couple of questions? Okay.
Yes, I go to the Q&A, right?
Yes, the last one, I will, it's for you. Do you foresee an end soon to chip shortage crisis, considering the measures taken?
Well, I think this chip shortage crisis was not predicted. I think the main reason is the stick mark recovery. And there, the need for chip shortage is also a bit interlinked with COVID. So the more you work from home, the more digitalization you need, the more appetite the world has for semiconductors. And on the other side, the overheating in the demand is not understood at the moment. So I think this one we cannot really answer for our customers. We have our big customers. We have a very close one-to-one collaboration to avoid the worst, which is line downs. But I think predicting when this chip shortage will end is almost impossible at the moment. So the measures for us, capacity increase, vaccination is working well. Also, maybe before was a little bit of question of reshoring or offshoring. At the moment, we don't think that for semiconductor industry, the globalization will stop. It is actually, at the moment, we are doing quite well to have global flexibility. So if there is a problem with COVID in one part of the world, we may be able to solve this on other parts. But the answer when the chip shortage crisis is over, I cannot really answer.
So you think it will continue in 2022?
Yes. For 2022, it looks like it will continue into 2022 at the moment, yes.
Okay. Okay. So there is a question about the bullwhip effect. Okay. He's asking you about the, can you elaborate how can we ensure supply chain visibility to reduce bullwhip effect?
Yes. So this bullwhip effect, so despite visibility, bullwhip is still there. As I mentioned before, so when we have systems implemented like this vendor managed inventory, and we replenish by reach, then you already have in the system a bullwhip. On the other side, humans just tend to that when you need to order something and you have nothing in your stock, then you usually order twice as much or you order just more. If your stock is very high, you tend to order much less. So overcoming this bullwhip is not an easy part. Visibility definitely helps, but also tools need to be implemented where the bullwhip is not amplified by the tool itself, like this reach steering. So it is a collaborative way, but I think, and Douglas also mentioned that we have done, I think, quite good in supply chain as long as we concentrate on a company and on one-to-one relationship. But for a network thinking, we definitely need to work more on that. But of course, this also makes it very interesting for us being in supply chain to come to this challenge.
Okay, thank you.
And then there's another one on S&OP, right?
Yeah, please.
So this S&OP, so how did we implement this S&OP? So for us, I think the first topic is we have accepted that we need to be flexible and global. And after we have accepted to be flexible and global, the next topic, of course, was to have 100% visibility. 100% visibility is we need to know if a certain later ATP is still in a factory, or it is already in transit, or it already in the distribution center. Because if you don't know what you have aligned in the factory and in transit and in the distribution center, then an ATP doesn't work, because then you might count it double, or you don't cut it, or you don't count it at all. So visibility is an absolute must for implementing something like that. As a next step, we found out that we are much better when we also implement this commit process. I will show that for a moment again to come back to the slide from where also Shireen was asking before. Okay, so here for everything what is already started has a commit process. So we have a commit from the factories that something is coming into the distribution center. This one stabilized this global supply chain a lot. And only after we had this commit process, the whole system of this advanced planning system really worked well. So an important topic was this commit process. But your question actually was on the S&OP process. So what I show here on the production program is already one below the S&OP process. The S&OP process is actually here. That's larger than six months. Here we do the same. We also have a demand. We also have aggregated capacity. And here we do scenario planning. But what was important here for the S&OP process is that the S&OP error doesn't go down, but the operational demand error goes up. So whatever we have in the next 6 months, because that's roughly our cycle time, whatever we have here as a demand on the operational level, this has to be one-to-one the same in the S&OP process. By that, we ensured that the operational process is aligned one-to-one with the S&OP process. So this operational process becomes the key for the near future, but for S&OP, you also need partially the near future in it. So that was an important topic. And what I also mentioned before is that this is not one tool. There are several tools like this advanced planning system from Blue Yonder, the demand fulfillment also from Blue Yonder, order management being very close to the accounting system is from SAP. This commit process is our own developed part. Yeah. And visibility and lot tracking. So manufacturing execution system, for example, this one is from another provider who is very strong in semiconductor manufacturing for merging and splitting. So it's a best of breed IT tools, but the key for making best of breed IT tools working is an aligned master data system. Does this answer your question?
It's okay. Thank you very much. Thank you for spending your weekend with us as well. We highly appreciate it, Hans. Thank you so much.
You're very welcome.
So now we will move to the second part where we will have someone is writing for you in Arabic. Shukran, Hans. Thank you, Hans. She's writing your name in Arabic, by the way.
Thank you.
Okay. It's fantastic. We can just thank you more. Thank you for the elaboration and the quality of the feedback. Thank you very much.
Thank you. Bye-bye.
Thank you.